Wait, what if I told you that the AI boom is growing so fast that data centers could more than double their electricity use by 2030, pulling as much power as an entire country like Japan? And in the United States alone, government analysts now warn that data centers' electricity demand could double or even triple by 2028 if AI keeps scaling the way it is.
So, are we accidentally building an AI future that breaks the grid, right when we're trying to decarbonize it?
Today, we're asking one brutal question. Can the clean energy transition and the AI revolution actually work together? Or are they on a collision course? If you care about energy, climate, or just want your lights to stay on while AI trains in the background, stick around.
Before we dive in, hit subscribe and like this video so we can keep unpacking the real stories behind the world's biggest green infrastructure projects.
Welcome to the Green Blueprint. In our last episodes, we focused on how we store clean energy, gravity batteries, pumped hydro, and giant grid batteries that act like shock absorbers for renewables. But there's another shock building on the demand side. AI data centers that run 24/7, slurping power like small cities.
Okay, first things first. How big is this AI electricity problem really? Are we talking extra Bitcoin miner in your town? Or new industrial revolution level?
Let's put numbers on it. In 2024, data centers used about 415 terawatt hours of electricity, roughly 1.5% of all the electricity on Earth. The latest International Energy Agency projections say that by 2030, that could rise to around 945 terawatt hours, more than double, driven heavily by AI workloads.
That's like adding another major industrialized country to the grid, just in server racks.
Academic and industry reviews of data center energy show the same pattern. AI and cloud computing are driving a 160% jump in data center energy consumption, mostly from massive compute and cooling loads. In some regions, single AI-focused data centers already draw as much power as a small city, and local utilities are warning they might hit their capacity limits within just a few years.
And that's before we electrify everything else: cars, heating, industry.
Exactly. One US Department of Energy report now expects domestic data center usage to double or triple by 2028, even as we're trying to clean up the grid for EVs and heat pumps. If that demand is met with new gas plants and coal extensions, several analysts warn it could slow or even reverse parts of the clean energy transition, a kind of reverse transition back to fossil capacity.
So AI, the tool that's supposed to help us solve climate change, might actually raise emissions if we're not careful.
There's also the grid stress side. AI data centers want constant, high-quality power. No flicker, no voltage dips. Studies show they can create local congestion, distort power quality, and force expensive grid upgrades that regular households end up paying for.
And I've heard about the water angle too, cooling all that hardware.
Right. Several reviews now flag cooling as a major local water and energy burden, especially where data centers cluster in already stressed regions.
So if we zoom out, AI is stacking big new loads on grids that were already struggling to add renewables fast enough.
That's the collision risk. But it's only half the story.
So, is this just doom? Or are people actually doing something clever about it?
A lot of clever things, actually. Let's start with how data centers themselves are changing. Recent research on green and secure data centers shows that combining efficient hardware, advanced cooling, and AI-driven resource management can cut energy use by around 20 to 25%, while also improving cybersecurity and reliability.
So AI helps reduce the energy of AI? A bit meta, but I like it.
Another academic review lays out the main mitigation tools we have right now: energy-efficient chips and servers, advanced liquid cooling, co-locating data centers with renewables. and aggressive heat reuse and power usage effectiveness targets. But the real magic happens when the grid itself gets smarter. Across multiple studies, AI is already being used for better demand forecasting, predicting peaks hours or days ahead, so operators can schedule the cheapest, cleanest mix of power plants and renewables.
So instead of the grid guessing how hot tomorrow will be, AI looks at weather, historical demand, and real-time data and says, here's the curve, minute by minute.
Exactly.
A recent AI for Grid paper shows how neural network models can optimize microgrids with solar and wind in real time, improving stability and making it easier to hit SDG 7, affordable, clean energy for all. Other work on AI-integrated grid systems highlights intelligent monitoring, fault detection, and dynamic control that can reduce outages and integrate more renewables without massive overbuilding.
So AI is both the problem load and part of the control system keeping everything stable.
Then, there's flexibility. One 2024 study looks at how vehicle-to-grid V2G, using EVs as mobile batteries, could help absorb AI-driven peaks, acting like a swarm of tiny storage units that discharge when data center demand spikes.
That's wild. Your car could be helping power the server farm that runs your AI assistant.
Policy is starting to move too. The European Parliament has flagged the need for sustainable integration of data centers into the energy system, which means planning them into the grid like critical infrastructure, not random buildings. And in 2024, the US Department of Energy released a report on how AI can accelerate a 100% clean electricity system by improving planning, speeding up renewable deployment, and boosting grid flexibility.
So from the innovation side, the message is AI plus smart grids plus storage can actually help clean energy scale faster.
Yes, but only if we design the rules and the infrastructure around that idea.
Okay, let's time travel. What does a sane 2035 look like, where AI and the clean energy transition actually work together?
A recent review on the energy and climate alignment of AI infrastructure suggests 3 big moves. First, co-location and coupling. Data centers get built where there's abundant clean energy, next to major wind and solar regions, hydro corridors, or even future small modular reactors. So new AI demand pays for more clean capacity instead of locking in fossil fuels. Second, flexible operation. Instead of training huge models whenever they want, operators time shift the most energy-intensive jobs to moments when the grid is flush with wind and solar, and dial back during stressed hours, something several scenario frameworks now explicitly model.
So if there's a massive windstorm at night, the grid says, cool, go train your model now. But on a hot, calm afternoon, you scale back.
Exactly. The latest technical work on AI data center loads even explores energy-aware prompting and demand response, where user requests and model choices adapt to grid conditions in real time. Third, hard constraints and transparency. Policymakers set clear energy and carbon intensity limits for data centers, publish standardized metrics, and require them to participate in demand response and capacity markets, so they behave like grid assets, not black boxes.
Basically, if AI wants to be a huge new customer, it has to help keep the lights on.
There's still real risk. Analysts warn that if utilities blindly overbuild fossil generation to chase speculative AI demand, we could lock in decades of extra emissions and higher bills for ratepayers. But the same analyses also show that demand-side management, renewables, storage, and smarter grids are often the fastest and cheapest way to meet near-term load growth, including AI, without breaking climate targets.
So, answer the original question for me. Is AI colliding with the clean energy transition or helping it?
Right now, it's both. Unmanaged, AI data centers can overload local grids, push up electricity prices, and force a comeback for fossil plants. But designed well, with co-located renewables, flexible loads, V2G, and AI-driven grid control, they can fund new, clean infrastructure, stabilize renewables, and speed up the transition instead of slowing it down.
So the real question isn't, is AI good or bad for the grid? It's, do we choose AI with a climate-aligned grid plan or without one?
If you want to see the physical projects that are already reshaping this story, gravity batteries, pumped hydro, and mega-scale clean energy builds, check out our Global Projects series right after this video.
And if you learned something today, hit subscribe, like this video, and share it with someone who keeps asking whether AI is worth the energy.
This is the Green Blueprint. Thanks for watching, and let's build a future where AI and clean energy push in the same direction, not against each other. Stay green, stay healthy, stay informed.